Have you ever pondered how your smartphone recognizes your face? Or how your email filters out spam? Deep learning makes this possible. It's a fascinating area of artificial intelligence that enables our devices to learn from experience, just like we do. Whether it's your phone picking you out from a crowd or your email service effortlessly weeding out unwanted messages, deep learning is quietly working behind the scenes. It even powers the voice recognition technology that we increasingly rely on, so let's dive in and unravel the mystery of deep learning. In essence, deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. But don't let these terminologies intimidate you. Let's break it down, shall we? Let's consider the process of teaching a child. When you show a child an apple numerous times, they start recognizing the apple, don't they? The child learns from repeated exposure and starts identifying apples on their own. Similarly, deep learning algorithms learn from vast amounts of data. They go through millions, even billions of examples, learning to identify patterns and make predictions. It's like teaching a child, but on a much larger scale. And here's the fascinating part. The more data the algorithm is exposed to, the better it gets at making predictions. It's continuously learning, adapting, and improving, just like a human brain. Think of it as a virtual brain, learning from experience and making better predictions each time. Now that we understand what deep learning is, let's delve into how it works. Let's begin with neural networks, the backbone of deep learning. Picture a neural network as a team, and the team members are individual nodes or neurons. Each of these nodes has a specific role in processing the information they receive. Imagine a game of telephone where a message is passed along from one person to the next. Only in this case, the message is a piece of data and the people are nodes. The first person, or the input layer, gets the original message or data, and passes it along to the next person, or the hidden layer. Now here's where it gets a bit tricky. Each node in the hidden layer has a weight, which is like a unique filter that slightly changes the message. It's like if each person in our telephone game whispered the message with a different accent. These weights are initially set at random, but as the game goes on, they're adjusted based on how close the final message or output is to the original. This is done through a process called backpropagation. The goal is to get the final message as close to the original as possible. And so, the weights keep changing, with every round of the game, improving the accuracy of the final message. Essentially, deep learning is all about tweaking these weights to reduce the difference between the predicted output and the actual output. To truly grasp deep learning, let's consider a real-world example. Imagine a recommendation system like those utilized by Netflix or Amazon. These systems are prime examples of deep learning at work. They analyze vast amounts of data about a user's behavior and preferences, such as their past purchases or the movies they've watched and rated. By processing this information through layers of artificial neural networks, these systems predict what the user might like to watch or buy next. Let's say you've been binge-watching sci-fi series lately. The deep learning algorithm picks up on this pattern and starts recommending more sci-fi content. Or perhaps you've been buying a lot of gardening tools on Amazon. The system will then suggest other gardening-related items that you might find useful. This is deep learning, making sense of complex patterns and predicting outcomes with astonishing accuracy. So, the next time Netflix suggests a movie you might like, remember, that's deep learning in action.